Let's start with first questions. There's no need to simplify answers to all your differentiation. And in part A, you can see clearly that right here, this is a quotient. The bottom part is the square root of x, and the numerator is 1 minus x cubed. So if we let u be this and v be this, derive both respect to x, and push those all this into the quotient rule formula, and you should get this. Okay, and for b, you can see that this is really a product of two functions. You can think of the first function being u as the square root of x, as you can see here, and whatever in the parenthesis, 2x squared minus 1 over x is v, and derive both again and push them into the product rule formula, and you have that. And finally, the last one, a bit tricky, but still it's not really that difficult. If you first do some manipulations, you reach this stage. Here we derive all of the terms by x squared, because we want to find a common denominator, and in the end we combine all four terms together to form this. And now what we do here is we reciprocate both sides. So sort of flip this from 1 over y to y, and we flip this so that x squared become the one at the top, and this long expression become the one at the bottom, the denominator. So we get this. So, and again, employing the quotient rule, you should get this. Of course, if you are not too sure, the x squared will be a u, and this long term, long expression here will be your v. Now moving on to the next one. So here we are asked to use first principle rule to derive this where x equals to 2. So the few ways you can do it, but here I'm going to use this definitions. So f prime a is equal to these definitions. So you can see that when I push all these values in, fx, f2, x minus 2 here, and then we have to be careful when we substitute the fx and f2, and we write here. So some of us would be curious about how we actually got this, and to reach to this stage here, well, I want to show you that 1 over 5, okay, is really this. You know, when you look at the 1 over 5 and 1 over 1 plus x squared, you combine to one big rational expression. You have this. What happens then is, because we are actually dividing this expression by x over x minus 2, you can then think of this as x minus 2 times 5, 1 plus x squared. And of course the numerator will still be the numerator of the resultant, and here that's why we have this, and then so you can see the working, and finally the value is 4 over 25. Now moving on to the third questions, some careful considerations put in place here. Firstly, you can see this is 4 meters and 6 meters the actual tank, but we care also about the actual volume of water, and 4 meters in diameter means that we're really talking about 2 meters, and the height is still be 6, and hence we have this right angle triangle here of 2 and 6, and then we sort of like sketch the volume of water in a cross-section view to also be like a right angle triangle, where we assume that the radius at the top of the water is r, and the height is an unknown height, is h. Okay, so that's why we have this smaller right angle triangle, and the similar triangle says that the ratio or the corresponding side are the same. So you can see that if or something like this, so you can take 2 divided by 6, it will be equivalent to r divided by h, because they are really similar, although one is slightly larger than the other one. So you have this. So we got the relationship h equal to 3r, and that's what we really were supposed to do. So in the part B, Hence they ask you to find the volume. So the volume formula, yes, given here is the volume formula, and all you need to do is just, of course, replace the H in our case with 3R, and you end up getting this relationship. So now what you can see is that we have 3 unknowns or 3 variables: V, R, and H. Pi and 1/3, they are just constant. But at the end of the part B, we only left with R, the variable R, and V. That's a very important idea. So now let's continue to the part C of the same questions. Okay, so now read through this. Okay. Give yourself some time, maybe stop the video and read first. Anyway, they ask you to show or prove this, and given that the capacity of the tank is 4 liter, of course 4 liter is really 4,000 cm cube. So from the answer in part B, we equate them, replace the volume with 4,000. Working will end up giving us the H relationship with H and R. But another thing is that total surface area is something that given here, you can use this idea. The slanted area length rather is really in the triangle that we're talking about, or the cross section of the volume water. It was R, if you recall, and H. Of course, then the length of this will be R squared plus H squared by Pythagoras theorem. So we really talking about this slanted length here, and so that we sub that in, and so you can see why we have this. The A, pushing it everything here, but just referring to here, and finally this is what we need. So I hope you get the idea how to use firstly the similar triangles idea, and also this how to use hint given to you if there is such a hint given. In this case, the surface area cone is given to you. And the next thing is you're supposed to sketch a graph of A against R. Well, you could use a graphic calculator, and by using a graphic calculator, it allows you to get the solution to part 2 and 3. So I'm going to first graph, and then I'm going to sketch it in right here. So if you use a GC and set it appropriately, of course, you have to enter use X to replace all the R squared and R. Anyway, you be sketching this. Make sure you label the AX, and of course this is R, not X. Okay, or it should be AR. Maybe I should do it more properly. So this is AR, and this R here, this axis, and the curve will look something like this. Just sketch it, and use the solution feature of the GC. You should be able to calculate that this is about 11.053 but 5, and this is 1535.3. This approximation. So that is how the curve will look like. And if you ask to find the dimension of the conical tank chosen, so that of course clearly the X is your radius, so the radius is 11.05. You can see it from here, and the height of 31.3 is due to relationship that we have seen earlier, that we form from right here. H is equivalent to 12,000 divided by pi R squared. Of course, in this case, your R is, you replace the R by 11.05. That means you'll be calculating H equivalent to 12,000 pi of 11.05, I think is power 3. Yeah, square this. And this should give you 31.3. So that's how you respond to these questions. I'm going to move on to the next questions. And when you're being asked to solve this and leave the solution or roots rather in exact form, so try not to use a technology like calculator to help you, and use the quadratic formula, and so leave the answer like that. Okay, and there's one more thing. Okay, right here, this is where we see that given this relationship, it's supposed to find the values of A, B, C. Of course, there are a lot of ways we can do this. One way is that we expand this right hand side, and then we compare the coefficient of each terms. Another way is by division. So what I have done here is that I divide both sides by x plus 1, and so this becomes, so that I rearrange so that this becomes my left hand side, and this here, the right hand side here is this particular whole expression divided by x plus 1. Remember that I divided the first expression or first equation by x plus 1, so we end up seeing this. What we need to do now for the right hand side is to do a long division of polynomial. If you do this, okay, how to do this? Very simple. Now this x cubed, you just look at the first term of each expression. In this case, the x plus 1, you look at the x. For this one, you look at the, well, you get the idea later. So look at the x cubed. Now, what will you multiply x with to get x cubed? Okay, I asked you to. So clearly, the best thing that you could do is to multiply it by x squared, because x squared times x gives you x cubed. So here we have x cubed. Of course, you're supposed to do something to 1. So x squared and 1 will give you plus x squared. And in the long division, it's supposed to subtract each and every time. Subtracting x cubed and x cubed give you nothing. Minus 3x squared minus x squared, that would leave you with negative minus 4x squared. Not enough term for us to perform the next calculation, so we sort of like bring down the negative 3x, and again we ask ourselves, what do you times x with to get negative 4x squared? And so that would have to be negative 4x. As you can see, if you use negative 4x times x, will give you negative 4x squared. And that we see the logic and rationale of doing this later, why we choose negative 4x. See, when you now take this one and times the whole of x plus 1, this will leave us with x minus 4x squared and minus 4x. And once again, we subtract again. This subtract this will be 0. You see the rationale there? We want to eliminate the negative 4x squared. So we choose something that when we multiply with x gives us this term, which you kind of cancel out this. And the minus 3x and minus 4x would give us 3x minus negative 4x plus becomes x. And again, not enough term, we get this. As you can see, this is x plus 1. It's x plus 1. The best choice is then to multiply by 1. And you get x plus 1. Then you're done. So in other words, you will get something like this in the end. So after you perform the long division, you end up seeing the x squared minus 4x plus 1. Think about it, why that is so. And because polynomial is unique in a way, so what you do is just compare the coefficient. X squared here, there's nothing. Well, there's actually a 1 in front of x squared. We can write because it's sort of redundant. Compared to a, so a is 1. Look at the coefficient of x. This side is in minus 4. So it implies that b has to be minus 4. And finally, implies that c has to be the constant 1. And then to draw the sign diagram, here actually we know a few things. We know that these two are actually a solution to the equation. Right here, this equation initially. Yeah. So, or rather this one, the whole one. Okay? they're related in that way. And so when you compare this, the outcome of this, right, is really what you got in part A. In other words, it implies that the solution to the roots rather to this cubic expression is 2 plus minus square root of 3, and another answer is the solution of x plus 1, which is negative 1. So the critical values that we know of, values of this particular function is negative 1 coming from x plus 1 and 2 plus minus square root of 3, which we actually discovered early on from here, which these two values are really the solution to this ax squared bx plus c. Now that we know the values of a, b, c respectively, so we substitute, we know that's the case. So the solution to this and this would be the roots of this and the critical values of this. So from here, you just use a sign diagram. Remember, take a value that's slightly smaller than negative 1, say negative 1.5, substitute into the calculator or something like that, sub into this function and check the sign. You will discover it's negative sign. I give you examples. Let's say I choose f of negative 2. As you can see, negative 2 is to the left of negative 1 is really less than negative 1. It's in this region. Again, what we care about is the sign. Sub into this one, minus 3 negative 2 square minus 3x plus 1, negative 2, sorry, plus 1. You find that this is going to be a negative value. Because it's negative, hence you put a negative sign here. Then choose a value between negative 1 and 2 minus 3. You have to use a calculator to find out. And check the sign of the calculation as you sub into the function and see what happens, and that's how you get the sign diagram. And finally, we actually can use the sign diagram to help us sketch this function. The function is right here, and it's cubic. We know that cubic looks a bit like this or like that, but where exactly it is probably we do not know, but we know some of the key values, key features of this particular graph, or of this function. From the sign diagram, you can see that, to the left of negative 1, the graph is in the negative part of the axis, positive between these two values, negative again and positive again. So what that means is, once we identify location of negative 1, I think 2 minus 3 is somewhere here, and then 2 plus 3 should be somewhere here. This is a rough sketch. And so again, to the left of negative 1 is in the negative, means that the graph has to be below the axis. So we're talking about something like this. And then now look at this, between negative 1 and 2 minus 3, which is this area here, it is above, so you're thinking about maybe the graph look a bit like up here, and then it's between these two values, or this root and this root is below. We're not sure where it is, but we simply just put a dot to indicate to ourselves. And lastly, this one. So it's highly possible, therefore, the curve should look something like this. Coming from the negative, passing through the root, negative 1. It has to make a U-turn like that, passing through the root again. Otherwise, it won't be able to meet the root again here, the x-axis here. It has to do a U-turn. Let me continue. Again, it's in negative. You can check the sign diagram between these two values. It should be in the negative, below the x-axis, that is. But it has to pass this point again. And the only way you can do that is that you U-turn and it does this. So this should be more or less what we are looking at. But of course you could just save yourself some time by using a graphing calculator and punch this thing into the calculator and get the sketch, and you can get the intercepts and turning points from the graphic calculator. That will be something that you should try and find out how. Lastly, let's look at the last questions. So here, clearly you're given an implicit function. What you do then is to actually ddx both sides, and because it's implicit, so you have to be careful of the expansion, the differentiation. Okay, small x. Now the right hand side minus 4 is a constant, so hence you derived it, it will be 0. The y cube was very simple, just differentiate it as if it's like a normal power rule, so it becomes 3y squared. But because it's the implicit, it's a dependent variable, so the implicit differentiation says that you have to times the 3y squared by dy dx. And then the next one is the minus, they put here, and 3x squared y is really, it is like a product rule. You can think about 3x squared as your u and your y as your v. So you can see that this is 3x squared times dy dx plus 6xy. So in case you're not sure what's going on here, the 3x squared y, when you differentiate it implicitly, think of it as your u v prime plus u prime v. Because the u is, we can think of the u as a 3x, so it becomes a 3x du squared. And the v, because we sort of kind of think of y as a v, when you differentiate y, it becomes 1, but because it's an implicit differentiation, it's 1 times dy dx. You always need to do that, times the dy dx when it's implicit. And u is 3x squared, you differentiate it, it gives you 6x, and the y will just be y, and that's, hence you can see why you see this thing within this parenthesis. And minus 6, because this 6x differentiate is just minus 6, 6 of course. So, and this is just algebra. Make sure you collect all the dy dx, and so in this step, and finally you have this. This is short. And then to find the slope of normal at the point 1, 2 is pretty simple really. First you need to calculate the dy dx, because to form equation of lines you need two things: the gradient and then also a known point on the line. In our case, okay, lucky for us, because the known point, which is 1, 2, is given, but we need the slope or the gradient of the normal, right? So at 1, 2, the dy dx, the sub of the xy value is 2, but this is the value 2 is the gradient of a tangent, and by the gradient of the normal, the gradient of normal is negative 1 over the gradient of the tangent. So in our case, negative 1 over 2, because we got 2 for m. Now we follow that principle. So to form this equation, just this equation of tangent, I think. But so this is how you find equation of tangent. But if you want to find equation of normal, that would be y minus 2 equal to negative half x minus 1. And simplification would give you the equation of normal. I think I do that. Simplify that. Negative x plus 1, and this should give you 2y plus x equivalent to 5. So here we have the equation of normal, tangent. I think there's a mistake with this solution, but never mind. And this is the equation of normal. Notice that the main difference is really the gradient of the tangent and normal. Okay. Alright, so hope you can do this, and all the best. Oh hi, I'm apologize for stopping the video too early. There's one more section, last part of the questions actually. Well, anyway, the equation of normal actually I calculated that in before I was trying to stop this discussion. So this is how you find the equation of normal. Right, okay, how we actually find the gradient or slope of normal is equal to 1 negative 1 over the gradient of tangent. So you got negative half, and that's how you get the equation of normal using the the method to find equation of straight lines. Then the one last bit is a bit challenging, but if you just be careful to think about it. They say here the normal found in part C touches the circle at one point. So in other words, they're trying to say that the function was something like this, whatever. And this is a tangent to a point, I think 1, 2. And the normal is, of course, perpendicular to the tangent is perpendicular. So this was a graph fx, the function that we derive implicitly. Don't care about that, don't worry about that. So what it's saying is that there's a circle right here somewhere, and this normal touches a circle right here. See it? At one point, that's the one point they're talking about. And in other words, this means that when you try to solve the equation of normal, this one, and the circle simultaneously, you will only get one identical answer, I mean repeated. You will get quadratic, you get supposed to get two answers, but the answers are repeated. As you can see here, we substitute the equation of the normal into this equation of the circle. Don't worry, just be patient and do the manipulations. You end up seeing this. And because there you're supposed to only get one answer, the not distinct, the repeated roots, means that the discriminant, or if you recall, the b squared minus 4ac would be equivalent to 0. And that is the meaning of this triangle thing, is discriminant. So once you perform that calculation, it's b squared minus 4ac. The b here you can see is negative 10. The a here is 5. And the c is 25 minus 4k squared. And then push those into this relationship, and eventually you're able to show the find the value of k that as required. Hope you find that the video is useful, and then all the best.